Most people compare AI model pricing the wrong way. They look at the price per token and think they understand the cost. But tokens are not equal across models. That is the tokenizer trap. Different models break text into tokens differently. The same prompt can become a different number of tokens, depending on the tokenizer. Code, whitespace, punctuation, and non-English text can all change the math. So when people compare GPT 5.6 and Fable 5 pricing, the sticker price may not tell the full story. The sticker price is still worth knowing. GPT 5.6 SOL is $5 input and $30 output per million tokens. Terra is $2.50 input and $15 output. Luna is $1 input and $6 output. But those prices only become meaningful after you know how many tokens your workflow burns, how many retries it needs, and how much human review it creates. The real question is cost per successful task. If one model has cheaper tokens but needs 5 retries, it may be more expensive. If one model has expensive tokens but solves the task cleanly, it may be cheaper in practice. If one model produces a huge diff that takes an hour to review, the hidden cost is human time. For developers, that hidden cost matters more than the token bill. Imagine 2 models fixing a bug. Model A costs less per prompt, but makes 3 wrong attempts and creates a messy patch. Model B costs more per prompt, but makes a small correct patch and writes a useful test. Which one is cheaper? Model B, because the real unit is not token. The real unit is finished work. This is why model comparisons should include 4 costs: prompt cost, retry cost, review cost, failure cost. Failure cost is the scariest one. If a model introduces a subtle bug, the real price may appear days later in production. That is why strong models can be worth paying for on high-risk tasks. But it also means you should not use them for everything. Use cheaper models for low-risk, easy-to-check tasks. Use strong models for hard tasks where mistakes are expensive. Use local models where privacy matters and quality is good enough. That is the pricing strategy. The GPT 5.6 versus Fable 5 debate should not be about which price table looks nicer. It should be about which model gives you the best cost per verified result. To test that, run a small experiment. Give both models the same 5 tasks. Track total prompts, total tokens, final correctness, review time, and whether tests passed. Then calculate the cost per successful task. That number is much more useful than price per million tokens. The tokenizer trap is simple. AI pricing looks mathematical, but real AI cost is operational. The cheapest model is not always cheap. The expensive model is not always expensive. The winner is the model that gets useful work done with the least total waste. There is one more trap: context size. Developers love sending huge prompts, entire files, logs, requirements, documentation. Sometimes half the repo. A larger context window makes that possible, but it does not make it free. If you send unnecessary context to an expensive model, you pay for confusion and cost at the same time. That is why retrieval and summarization matter. Before sending a task to GPT 5.6 or Fable 5, ask, what context does the model actually need? For a bug, it may need the failing test, the relevant function, the error message, and one nearby usage example. It probably does not need the entire repository. For a planning task, it may need the product goal, constraints, user flow, and existing architecture. It probably does not need every historical document. Good context control lowers cost and improves output. This is another reason pricing comparisons are misleading. A careless workflow can make any model expensive. A disciplined workflow can make a strong model affordable by using it only on the compressed relevant problem. So the pricing playbook is: route the task, trim the context, use the right model, verify the output, measure the full cost. Full cost includes tokens, retries, human review, and risk. Once you think this way, the GPT 5.6 versus Fable 5 pricing debate becomes much more useful. You stop asking which model is cheaper on paper. You start asking which workflow creates the most verified value per dollar. That is the only pricing metric that matters. A good closing example is a coding agent. Imagine your agent uses a premium model for every step. It reads all files with the premium model. It summarizes with the premium model. It plans with the premium model. It explains the final diff with the premium model. It explains the final diff with the premium model. That may work, but it is wasteful. Now imagine a routed version. A cheap model summarizes broad context. A retrieval step selects the relevant files. GPT 5.6 handles the difficult patch. Tests verify the change. A cheaper model writes the final summary. The result may be almost as good or better at much lower cost. That is how serious AI products will be built. The pricing conversation is not just about OpenAI versus Anthropic. It is about workflow design. If your workflow is wasteful, every model becomes expensive. If your workflow is precise, even premium models can be affordable where they matter. So do not ask which model has the cheapest token. Ask which system has the cheapest verified outcome. Prompt caching changes the math too. OpenAI says GPT-5.6 supports explicit cache breakpoints and a 30-minute minimum cache life. Cache writes cost 1.25 times uncached input, but cache reads keep a 90% discount. For coding agents, repeated context is everywhere. Same repo map, same style guide, same docs, same tests. If you architect caching well, the pricing picture changes. If you ignore caching, you may pay repeatedly for context the model has already seen.